Okay, now let's see this question. This question came in GATE 2014 for 2 marks. The question is, which one of the following Boolean expressions is not a tautology? Okay, so one of them is not a tautology and rest 3 of them are tautologies. Okay, so tautology is what? Tautology is a Boolean expression which is always true irrespective of what the values of the different variables involved are. Okay, so let's start with D first. So when I say that A implies B, I know that A implies B can be written as not A or B. Okay, so standard stuff. So in that fashion, uh, B implies A can be written as not B or A. Understand, right? So I have written D, I have written D like this. A implies and B implies A, I have written as not A or B. Now after that, again this implication can be changed, like it can be written as not A or rest of the things. So not B or A. Okay, and after that I can rearrange it like okay, it is basically A or not A or not B, not B. Okay, and then you can understand that A or not A, this will be always true. Why? Because if A is true, then it will be true or false, which is true, or and if A is false, then it will be false or true, so it will be true. So overall A or not A will always be true. Now if true, this thing is true, then you or true with anything else irrespective of what is the value of B, true or anything, this entire thing will always be true. So D is a tautology. Okay, now let's check C. In C, again it can be written as C, it can be written as not of A and B and C. So A and B and C, not of that, or C or A. So we have again used this formula, A implication B is equal to not A or B. Now how we take not of this? So not of this can be is basically De Morgan's rule. So not A or not B or not C or C or A. Okay, and now we can group them together like A not A. So it can be written as A or not A, and then it can be written as not B, and then it can be written as C or not C. Why I have grouped like this? Because A or not A, as here I said, it will always be true. C or not C, it will always be true. Now these are OR signs. So true, this is true, this is true, true or any value is always true. So irrespective of the value of B, not B, whatever thing is going to be, this entire statement is always going to be true, because true or any value is true. So C is also a tautology. Let's come back to A. So A is straightforward. A is in fact a rule also in logic. So what happens that when we say that A implication B is true, and see this symbol is and we say that B implication C is true, then from this we can imply that A is implying C, which is saying this. So this entire statement is basically a theorem in itself, which is called hypothetical syllogism. So this thing is definitely true always. So this thing is tautology. Now you understand that one of them has not to be tautology, that is going to be the answer. So the answer is going to be B. But we firstly let's justify that B is not a tautology. Let's understand B. So you know that, you know one thing, right? So A is equivalent to C can be written as A or A and not C, or not A and C. Okay. So not of this is written like this, and simply A is equivalent to C is basically, so basically what I'm saying is that it is sort of exclusive OR. So either A and B are of the same sign, so not A and not C, or both are of so both are either false or both are true. So A or A and C. So what I'm trying to say that when A is equivalent to C, it means that both are definitely always going to be the same sign. It is like exclusive OR. So either A and C, okay, both will be true or both will be false. And when we take a note of that, then what is going to be that one of them has to be true, another one has to be false. So my point is that and you can understand it like this also. So when A is equivalent to C, and this thing can be written in like in like digital expressions, digital logic also, you write it something like not A not B and plus AC, not A not C plus AC, you understand, right? So you understand that this thing is plus is basically OR, and this bar is basically not. So you can understand that what is happening is that you can write this like this also. So A plus C and into not A plus not C, and when you distribute it, then it will be A. So you can understand that what I'm doing is like that. When I'm taking not of everything, okay, not of everything, then it can be written like this, and then it can be A bar plus A C bar plus C A bar plus C C bar. This thing is true, this thing is true, and then you can understand is that overall it is going to be A C bar plus C A bar. Okay, so in here also we have seen that not of, so A C plus A bar C bar, and not of whole thing is basically A C bar plus C A bar, which here also I am saying that both are of same signs and they are odd. Then if we take not of that, then that, so this standard thing you might be remembering on your own also, but the only thing is that why I am doing this, because I am going to use this formula here. So when I am saying that A is implying B, A implication B, it can be written as not A or B. So basically I am going to take not of this or this. Firstly, let's uncomplicate this thing. This thing is already a implication, so it can be written as not A or B. So not of this first thing, which will be B itself, or A and C. Okay, it can be, this entire internal thing can be written like this, that, and after that this thing is going to be not A or of this thing. So or, and this thing is going to be not of this thing, and not of this thing is basically this thing. So this entire thing will come here. Okay, so overall how things are going to be, it is going to be A and not C, or not A and C, okay, or, and then from here we have to write everything B or A and C. Okay, now we have to see that whether it is a tautology or not. So what is happening is that this is not a tautology, and I will prove it by putting some values on which this thing will come out to be false. So my point is that if something is tautology, then irrespective of what the values or the variables you are putting, it should always come out to be true. But I will give you an example where let's say A and C both are false. A and C both are false. So if A is false and C is false, then what is happening, that A is false, C is false. Now if C is false, then not C is true. Okay, but false and anything is always false. Similarly, A is false, but not A is true. True and false, again this thing is false. Okay, so this thing is false, this thing is false. Now see, A and C, this is false and false, so this will also be false. So this entire thing is basically false or false or B or false. Okay, which is essentially equivalent to B only, because this entire thing will be true only when B is true. Otherwise, you know, this is false, this is false, this is false. So this thing can be true only when B is true. But if I take B also to be false, so in this case B is also false, then we can understand that this thing, entire thing will be false. So I have given you a assignment. A is equal, A is, when A is false, B is false and C is false, then this entire thing is going to be false. So for this particular assignment, since this is not coming out to be true, so that's why I cannot say that this every time true. That's why it is not a tautology. And that was the question, which of the following Boolean expressions is not a tautology? So the answer is B, which is not a tautology.